Geothermal versus nuclear electricity production methods. Global electricity demand increases by 5% annually, emphasizing clean production methods. Renewable and non-renewable methods are the two significant classifications of electricity generation. The disparity between renewable and non-renewable sources is that renewable sources are more sustainable and eco-friendlier than non-renewable sources. Geothermal and nuclear atomic energies are the most reliable renewable and non-renewable sources of power. Both methods are environmentally friendly, highly sustainable, and reliable. The Department of Energy, DOE, is tasked with long-term surveillance and nurturing of overall energy production in the U.S. to protect human health and the environment. Geothermal and nuclear electricity production methods compare for the most effective and sustainable method of electricity production. Nuclear energy is a non-renewable source created by the fission process of breaking uranium atoms. Reactors in a nuclear power plant contain uranium fuel composed of ceramic pellets, and the particles split into smaller bits in the fission process. Breaking the atoms releases energy used to make steam out of the water. The steam turns turbines that propel generators producing electricity, and the moisture is cooled back to water at the cooling tower, and the cycle continues. Nuclear energy accounts for 20% of American electricity production and 56% of carbon-free power. Atomic electricity production is a reliable, clean energy source with zero carbon impact on the environment with guaranteed constant power production for 24 hours a day. Apart from nuclear fission, nuclear fusion and nuclear decay are also methods of atomic production. Electricity produced through nuclear reaction applies to everyday life for heating, cooling, refrigeration, public transportation system, and running electrical machinery. Nuclear energy also has medical applications in the radiation process used for cancer treatment. Nuclear power is a non-renewable source that leverages atomic reactions to produce green energy. Geothermal power is a renewable method of electricity production using steam. Geothermal power relies on the hydrothermal supply of water, hydro, and heat, thermal, sources such as dry steam and hot water wells. Geothermal reservoirs provide steam that drives turbines to produce electricity. There is no burning of fuels in geothermal production, hence minimum carbon production. However, the process emits excess moisture mixed with small amounts of gases. Dry steam plants, flash steam plants, and binary cycle plants are the most common geothermal plants. Geothermal production accounts for only 0.4% of America's net electricity generation. California, Nevada, and Utah are the three states with the highest geothermal output in America. The minor use of geothermal power is due to the significant capital investment essential since every kilowatt established requires $2,500. Geothermal energy is mainly used in heating systems for fish farms, pasteurizing milk, and drying crops in the U.S. Geothermal electricity is also used in 27 countries with a total production of about 15.4 gigawatts, with the U.S. leading at 3.68 gigawatts. Both geothermal and nuclear power production methods are environmentally friendly. Compared to methods that invoke burning fossil fuels, geothermal and nuclear energy are significantly cleaner sources of energy. According to DOE, atomic energy has zero carbon emissions, whereas geothermal power produces very little carbon mixed with excess steam. Unlike methods that involve burning fossil fuel, geothermal and nuclear methods bring forth little to no carbon emissions producing clean energy. Power plants are sizable and can potentially produce greenhouse gases contributing to air pollution in significant amounts. Moreover, the generation technology for geothermal and nuclear production is similar. Both methods run steam turbines and have steam condensers and cooling towers in their infrastructure. Steam is the fuel used to run both technologies, tapping on heat generated by the decay and action of radioactive components. Setting both projects requires a minimum surface footprint, hence encouraging optimal land use. Geothermal and nuclear methods of electricity production are much more consistent in the type of fuel they utilize and their technological structure. The two generation methods are also equally efficient and reliable, with the capacity to produce large volumes of electricity. Geothermal and nuclear power are huge potential production methods with applications in agriculture and heat pump manufacture. Radioactive materials from atomic energy are used in food radiation to expand the shelf life of foods and pest control using the sterile insect technique in agriculture. In higher altitudes areas, geothermal energy is used to dry crops and grains and thermoregulate agricultural soil, water, and greenhouses. Nuclear and geothermal-powered heat pumps are energy-saving thermoregulators used in houses, refrigerators, and boiler systems. Both geothermal and atomic energy are beneficial in agricultural production, and heat pumps are manufactured to support daily life. Unlike nuclear energy, geothermal energy is a renewable method of power generation. Non-renewable energy depends on sources that need regular replenishment over a lifetime, whereas renewable sources do not require frequent replenishment. The uranium needed in nuclear production is rare compared to vast Earth crusts with hydrothermal components. Enhanced Geothermal System (EGS) can make artificial reservoirs in crusts with less permeability and fluid saturation. The geothermal energy source is better since hydrothermal is self-replenishing, unlike rare uranium fuel. Additionally, nuclear production is more complex, costly, and risky than geothermal production. Geothermal requires less startup and operation costs compared to nuclear. Nuclear technological infrastructure is complex, and operations costs are high due to the rare nature of uranium fuel and specialized high-skill labor. The exorbitant cost of nuclear energy discourages businesses from choosing it as a method of power generation, leaving only the government to exploit the technique. Nuclear plants require heavy monitoring and regulation to curb radioactive waste. The accidental release of radioactive material from the nuclear process is also lethal to life. Geothermal energy reinstalls the salts and minerals in the excess liquid because the water in the reservoir is recycled. Nuclear and geothermal electricity generation technologies are relevant to bridge the future in present energy demand and supply gap. Rapid urbanization and the surge in global population call for research and evaluation of the different electricity production methods. Power production organizations, governments, researchers, and environmental conservatism ought to know how practical these methods of power production could be. Understanding the metrics of different ways of electricity generation is elemental for decision-making and research on the most accurate and sustainable approach to explore and incentivize. Nuclear and geothermal power are eco-friendly and dependable electricity generation methods that use steam to drive steam turbines. Geothermal-produced steam requires heat and water from the Earth's crust, whereas nuclear energy requires uranium fuel for the fission process. Geothermal energy is, however, better than atomic energy, is more sustainable, reliable, and poses minimal risk to the environment.